Hello, dear students. This is my second lecture on chemical kinetics. In my first lecture, I explained about rate. We learned to define rate, and also we learned to write the mathematical expression of rate. And followed by we learned uh, rate constant, rate law, and order of chemical reactions. Um, Here in the second lecture, uh, I'm going to solve a few problems based on what we have learned in the last class. This is a very simple problem. Uh, Here we are going to derive unit for rate constant, zero, first, second, third order. Look at the problem. Starting from the full rate reaction, determine the units of the rate constant K for a zero, first, second, third, and the off order reaction. So they are asking us to uh, determine the unit, to find out unit of rate constant for all the given orders. Let me first derive order for zero order reaction. So we learned that a zero order reaction rate is directly proportional to um, a concentration. Power zero. This is for a zero order reaction. Therefore, rate equal to K times, that's all. A power 0 is 1. That's all. So rate equal to K. This is the rate equation for zero order reaction. What is order actually? Order is actually uh, the, the the sum of power of concentration terms in the rate law. That is order we defined. So here 0 is the order, because this is 0 is the power to this concentration term in the rate equation. So this is 0 order, no doubt. And now I'm going to write the expression for the unit for this rate constant K. Right? Rate is actually defined as, we learned last class to define rate. Rate is actually defined as change in concentration. Change in concentration with the time is called rate. Change in concentration is mole per liter. Time is second or minute. Let me take second. Therefore, rate equal to mole per liter and second inverse per second. This is the unit of rate. And we know that liter is, in terms of decimeter, we'll say that 1 liter is equal to 1 decimeter cube. Therefore, the rate, unit of rate is also written as mole per decimeter cube per centimeter. Okay, then this is the rate equation for zero order reaction. Therefore, the unit of rate is mole per decimeter cube and per second is equal to K. So this is the rate constant unit for rate constant of zero order reaction. Then for the first order reaction, a rate equation can be written as rate equal to K, it's a rate constant, and A, it's a concentration of reactant A, power 1. This is a rate equation for first order reaction. Here I know rate is expressed in the unit of mole per decimeter cube per second. So I'll write it's mole per decimeter cube and per second. I don't know the unit of K of first order reaction. Concentration power 1. This is concentration power 1. Concentration is expressed in mole per decimeter cube or mole per liter. So therefore K equal to let me write one more step, mole and decimeter inverse or mole per decimeter cube is mole per decimeter cube per second. So I can strike out, therefore K equal to second inverse. K equal to second inverse is the rate, is a unit for rate constant of first order reaction. This is for first order reaction. This is for zero order reaction. And see, for a second order reaction, let me write second order K, it may be a power 2. The rate constant, rate equation may be of this kind, or rate equation will be of this kind, or rate equation will be of this kind when two reacting molecules are involved, or even the rate can be of this kind, a power 0 and b power 2, whatever it may be. So these are the different kinds of rate equation. I said in my last class that rate equations are actually uh, determined experimentally. Rate equations are constructed experimentally. Okay, then we'll write rate is mole per decimeter cube and per second. Sorry, per second is K. This is A is concentration, is mole per decimeter cube square. Therefore mole decimeter per mole per decimeter cube per second, K is mole square decimeter inverse, 6 times 3 into 2. Therefore I can strike out the mole. Here I have mole square and decimeter cube, here decimeter cube, here 2 times. So this side second inverse, and this side mole will remain, and decimeter per cube. Therefore K equal to mole inverse and decimeter cube and S inverse, or let me write decimeter cube per mole and per second is the rate constant, unit of rate constant for second order reaction. Second order reaction, right? Then for a third order reaction, so if you work out rate k a power q, then k will be decimeter, okay, power 6. If you work out, you will get decimeter power 6 and mole inverse 2 and second inverse 1. You just work out, and then finally we'll have to find out order, off order reaction, unit for off order reaction. And if you work out, you'll get unit, this is for third order, and for off order reaction, work out by yourself. The unit will be uh, mole power of decimeter power minus 3 by 2 and second inverse. So this is how you have to work out units for rate constant for a given order.